In this video, we're going to talk about solving quadratics using square roots. So in our first example, we've got x squared minus 49 equals 0. So I notice it's a quadratic because it's got the x squared, but I do notice that I don't have the bx term. So anytime that I've got an x squared, but I don't have my bx term, but I do have my c, I can think about using the square root method. So if I want to do the square root method, I'm trying to get x by itself. So the first thing I'm going to do is get rid of this minus 49 by adding 49 to both sides. When I do, that cancels out, gives me x squared equals 49. So then I'm trying to get x by itself. I'm going to square root both sides. That's going to give me x equals positive and negative. Square root of 49 is 7. So my answer is x equals 7 and x equals negative 7. My next example, I've got x minus 5 squared equals 36. So I've got to get rid of my squared here, try to get x by itself. So I'm going to square root both sides. When I do that, that's going to give me x minus 5 equals plus and minus. Square root of 36 is 6. So then I'm going to split this up because I've got a plus and minus into two parts. X minus 5 equals positive 6. X minus 5 equals negative 6. I'm going to add 5 to both sides here. So x equals positive 11. Add 5 to both sides here. X equals negative 1. So my answer is x equals 11 and x equals negative 1. On the next example, I see I've got 3 times x plus 7 squared minus 2 equals 22. So remember, my goal is to try to get this x by itself, but I got a lot of stuff going on with that x. So the first thing I'm going to do is move this negative 2 by adding 2 to the other side. And so when I do that, that'll cancel, and that's going to give me 3 times x plus 7 squared equals 22 plus 2, which is 24. Now I want to get rid of this 3 that's out front. I'm trying to get rid of that 3 because I'm trying to get x by itself, and if I distribute out that 3, it causes me to have more work. So I'm going to divide both sides by 3. That'll cancel, give me x plus 7 squared equals 24 divided by 3, which is 8. So I'm trying to get x by itself. I'm going to square root both sides because the x is inside the parentheses and being squared. When I do that, that's going to give me x plus 7 equals plus or minus square root of 8. So at this point, I've got x plus 7 equals plus or minus square root of 8 is not a perfect square, so I can go to my calculator and do second x squared to get my square root, plug in an 8, and find out that the square root of 8 is 2.5 or 2.828. So x plus 7 equals plus or minus 2.828. So then, because I've got this plus or minus, I've got to split this up into two parts. X plus 7 equals positive 2.828, and x plus 7 equals negative 2.828. So then to get x by itself, I'm going to subtract 7 from both sides here. That'll cancel and give me x equals, go back to my calculator, 2.828 minus 7, negative 4.172. Over here, subtract 7 from both sides. That'll cancel. X will equal, got to do negative 2.828 minus 7, negative 9.828. The next example is very similar to the last one, so I've got 2 times x minus 4 squared plus 7 equals negative 20. So the first thing I'm going to do is get rid of that plus 7 so that I can get my stuff that's got x in it by itself. So I'm going to subtract 7 from both sides. That's going to cancel. And I have 2 times x minus 4 squared equals negative 27. Remember, I'm trying to get x by itself, so I'm going to divide both sides by 2 because that 2 is not directly touching the x. So that's going to give me x minus 4 squared equals negative 27 over 2. We're going to leave it as negative 27 over 2 for right now. Then I want to get rid of this squared, so I'm going to square root both sides. Whenever I do that, it's going to give me x minus 4 equals plus or minus. When I have a square root of a fraction, I'm going to do square root of the top over square root of the bottom. Remember, though, that I can't have that square root on the bottom, so I'm going to rationalize that denominator, which we haven't done in a while. That just means I'm multiplying by the square or the denominator over the denominator. And so that's going to end up being square root of negative 54 over square root of 4. And so that'll end up being square root of negative 54 over 2. 54 is not a perfect square, but I can break it down. 27 times 2 would give me 54. So then I can break 27 down to 9 times 3, bring down that 2. I can break 9 down to 3 times 3, bring down that 3, and bring down that 2. So then I've got a pair of 3's, which means square root of negative 54. I have to take an I out for that negative. So we put that there. And so my final answer would be 3i square roots of 3 times 2, which is 6. So this would be x minus 4 equals plus or minus 3i square roots of 6 still over 2. That plus or minus means break it up. So x minus 4 equals 3i square roots of 6 over 2. And x minus 4 equals negative 3i square roots of 6 over 2. So then I'm going to add 4 to both sides here. That's going to turn into x equals 4 plus 3i square roots of 6 over 2. I'm going to add 4 here, and that's going to turn into x equals 4 minus 3i square roots of 6 over 2.